All right, hello everybody, and a very special welcome to all of you who have taken time out of your day to join us here. Now, today we're doing something a little bit different. Instead of the usual presentation you've come to expect, say regarding some new great feature of NativeScript or the mobile app front end in general, today we're going to focus just on the back end of app dev, and I really use back end in air quotes as we no longer consider back end to really just be databases or storage, right? Now, there are a myriad additional services and capabilities rolled up into the cloud that we can leverage right now in both our mobile and web apps. So today, of course, is all about Microsoft Azure, and we're going to present the capabilities of Azure in the context of mobile app development with NativeScript. Now, I'm going to be honest with you here, much of what we show you today can be done equally as well on the web. Which this, of course, showcases the flexibility of Azure, but also how similar your skill set needs to be when developing native iOS and Android apps with NativeScript and the web. Before we get started though, I really need to run you through some basic logistics for this webinar. Now, if you can't hear me, haven't been able to hear me, or at some point the audio cuts out, please try connecting with your computer audio, not your phone. This is a very common issue with GoToWebinar. If that doesn't work, please just try restarting your viewer. And if all else fails and you can't watch the presentation live, or if you just want to watch it again, we will be sending out a follow-up email with a link to the video and links to some of the resources we present today. You can also find the NativeScript YouTube channel, where this video will live, at bit.ly/YouTube-ns. And now before we pivot all the way over to Azure, for those of you here who are new to NativeScript, you just need to know a couple of things right now. NativeScript lets you take your web skills and translate those into creating truly native mobile apps for iOS and Android. Yes, from a single code base. Yes, using JavaScript or TypeScript. Yes, using CSS. And yes, using a friendly HTML-like markup language. And yes, you can use popular front-end frameworks like Angular, like Vue.js, no framework at all. In fact, we also have a community-based support for React and Svelte now that you may be interested in looking at. And be sure to follow us on Twitter at NativeScript if you want to stay up to date on the various comings and goings around NativeScript and mobile app development in general. I also highly recommend you take a moment to subscribe to NativeScript News. We send out some really great info in this email newsletter, usually once a month or so. No spam, I promise. Just a monthly digest of some of the latest NativeScript happenings. So you can find back issues and a subscription form at nativescript.org/news. And when you start with NativeScript, you'll inevitably need some help along the way. One powerful community resource is Slack. We have over 13,000 folks on Slack today. Get your invite at nativescript.org/Slack. And when you do all this, you join a growing community of app developers who have now downloaded NativeScript more than 6 million times total. Okay, with that out of the way, how about some introductions? Well, the guy you see in the bottom right of your window is in fact me, Rob Lauer. I manage the mobility wing of developer relations here at Progress. Along with me today is TJ Van Tol, our illustrious principal developer advocate, and our developer advocate Stanimira Valeva, a former member of the NativeScript core team. And we are all super excited to be here with you today. So what I'd like to do is give a very brief overview of what Azure even is, very high level. I know it's confusing. I'm still confused by aspects of it, believe me. But the fact is that companies are moving to this mystical cloud thing really at a dramatic pace. Amazon with AWS, Microsoft with Azure, Google with their Google Cloud Platform, these have all emerged as the preeminent providers of cloud computing. Now, there is a reason for this, a very good reason, as more than ever before, large and small companies alike are working towards extracting as much value as they possibly can from their infrastructure costs. But why exactly are they moving to the cloud? Well, performance is one. The raw speed of cloud compute and storage is undeniable, but also the ability to respond to changing business needs helps these companies get their apps to market faster than before. Now, this is also helped by the scalability of the cloud. You can easily extend your business to the cloud as your business needs grow. The resources provided by any cloud provider should grow along with your business without requiring much of any interaction by your team. And we're also talking about a major reduction in complexity and therefore cost. Companies no longer need to maintain a massive infrastructure team, as these needs can be met in the cloud. And part of the performance aspect comes from the fact that cloud resources are spread across the world, providing vastly reduced latency. Regardless of where your company and your users are, you'll find an Azure locale relatively close to you. And when talking about payment with all cloud providers, you're effectively only paying for what you use. Sometimes. I say sometimes because there are some features in Azure that are also completely free. So from a raw infrastructure perspective, we can really envision how many tasks and responsibilities that were traditionally handled internally with high overhead can now be migrated to the cloud, either wholesale or on an ad hoc as needed basis. So again, what is Azure? Well, let's start with a basic description. So Azure is a public cloud computing platform which offers a variety of cloud services, including compute, analytics, storage, and networking. So it's more than infrastructure, it's also a variety of value-added services to bring additional functionality and capabilities to your web and mobile apps. In fact, I dug up this older diagram of Azure online, but it really still conveys the right message that what we think of as Azure is really a combination of a lot of different services. So it's up to us to pick and choose the right services for the task at hand. Which brings us to what we're going to specifically cover today. Now, while we could and maybe should string together about 20 webinars worth of content related to Azure, today we're going to limit ourselves to a sampling of some of the more useful and even fun aspects of developing a mobile app on top of Azure. Therefore, we're going to focus our time on Azure Functions. Now, this is the serverless computing service of Azure. We're also going to look at authentication, so the authentication features provided in App Center. We're going to spend some time on Cosmos DB. This is Azure's NoSQL data store. And finally, we're going to take a look at a sampling of Azure's cognitive services offerings. Now, you're probably thinking, what about things like Azure mobile apps or DevOps or a deep dive into App Center? These are all good, very valid topics, trust me, but certainly look for more content from us in the coming weeks and months on some of these subjects. But for today, I ask that you sit back and enjoy TJ Van Tol as he dives into Auth and Azure Functions. TJ, take it away.
All right, thanks, Rob. My name is TJ, and I'm excited to talk to you about two pretty powerful features of Azure and how you can integrate them into your NativeScript apps. The first feature is Azure Functions, which is Azure's serverless platform, which, as Rob discussed a bit, lets you write and deploy server-side code without having to worry about the backend infrastructure. Next, we'll look at Azure's App Services, which is a collection of features that just help you build mobile apps with Azure. So features like push notification and offline data sync, and authentication, which is going to be the main feature we'll be focusing on today. So those are our topics: Azure Functions and then App Services with a focus on authentication. And if you've seen any of my webinars or videos before, you probably know that I like to jump straight into the demos. So we're going to do just that. And we'll do these demos assuming we work for the fictitious Acme organization. Acme has a long history of working with NativeScript, and today we're going to look at how to integrate these Azure features into their NativeScript apps and their NativeScript workflows. So let's go ahead and get started. All right, I have my browser up now, and I'm on the Azure portal, which is available at portal.azure.com. And it's the first screen that you're going to see after signing up for a free Azure trial, which I did just a little bit ago. And from here, you can interact with basically everything Azure, which is quite a bit, but it does include the two things that we care about today, and that's Azure Functions as well as Azure App Services. And if I go into Azure Functions, as that's the first thing that we want to cover, you'll see that the first thing I'm going to need to do is create a function app, which is essentially just a way of building a collection of functions that you can group as a logical unit. And you can go through this form in the portal to create this app, but there's actually a second way that I prefer, and that's doing this through Visual Studio Code. Now, if I switch over to code, which I have open here, you'll see that I'm in a completely blank folder named Acme Functions. which I want to turn into a new Azure Functions app. So to do so, the first thing I'll need to do is head to the Extensions tab, where there is an Acme Functions extension for VS Code that you'll have to install. And once installed, you'll get this new tab in code for working with Azure. The first thing you'll be asked to do is log into Azure, which I've done, so it sees my free trial here. But you'll see that at the moment, I have nothing else here, so I have an empty free trial. And from there, the first thing I'm going to do is click this plus icon to create a new functions, or more specifically, to turn this folder into an Azure Functions project, which I want to do. You can write Azure Functions in a number of different languages, which is actually quite cool and something that you might want to play with. But since this is a NativeScript webinar and we'll be using these functions in a NativeScript app, I'm going to go ahead and go with TypeScript. Next, it's going to ask for a template for this new Functions app. And as you can probably see from this list, there's a lot you can potentially do with Azure Functions, working with data, triggering events, all sorts of things. But we're going to keep things simple and go with the most common type, which is an HTTP trigger. AKA, we want our function to run when we hit its HTTP endpoint. We'll name this first function Hello World, because we're, again, keeping things simple, and we'll allow for anonymous users to use the functions. As you'll see when we get into authentication, you can get more advanced for locking these things down, locking these functions down if you'd like. But again, Hello World mode, and we're just going to keep things dirt simple for now. And at this point, Azure generated our very first function for us, which is going to take a name query string parameter and just spit it out in the response body. So to get this to run, I will open up my terminal, and I will first run npm install, really only to get this TypeScript typings to fix my error right there. And then npm run start, which is going to run the necessary steps to actually get this endpoint up and running and allowing me to use it right away. And you'll see that it spits out the endpoint that I'm using. And so if I click this to open it up in the browser, it's going to want a name. If I pass a name here, I get that response body. Pretty simple, but hopefully this gives you an idea of just how easy it is to get started with Azure Functions, especially when working in Visual Studio Code. Now with this basic setup out of the way, let's bring NativeScript into the equation. And to do that, I'm going to switch over to the Acme NativeScript app, which I've gotten a little start on over here. And it's just a simple little app for Acme's employees to do Office-related tasks. And if I bring up the code for this app, let's drag some of these things out of the way. So I got the Functions app, and then the code for the NativeScript app over here. And as part of this app, I've set up a sort of skeleton service that's basically empty at the moment, and that we'll use to hit our new Azure Functions endpoint. Now, this is an Angular app. You can use Azure Functions regardless of what NativeScript architecture that you use. But in Angular, the way to hit an endpoint, we're going to call this.http.get. And I'll need to get the actual URL. So I will do that. Actually, I'll grab it with the query string as well. Pass that here and return it. And if I do that, I can head then into the component, which is actually driving this screen in the app. And I'll add a quick call that actually hits that services method and is just going to log any data that comes back from it. And if I do that and then drag over my terminal, you can see that I'm now successfully getting that log, getting that data, hitting that endpoint successfully. I do want to make a change to the Functions app just so you can get a sense of how all of this workflow sort of comes together. So what I'm going to do is switch back over to the Functions app, give myself a little bit more space, and I'm just going to simplify this code a little bit to return JSON. So including a header to tell NativeScript and to tell the browser that this is coming back is JSON, and I'm passing a simple greeting property. And with that change in place, I'm going to go to NativeScript, and I want to change this string I have here to use that dynamic property. So if I say, now that I'm getting this greeting back, I can grab it from my endpoint, data.greeting, and then I'm going to head into my markup and bind data here. So instead of hard coding this, I will switch over to my greeting, save that. And so that we can see this all work together, let's switch our name so we get the full workflow and switch over to Rob. And what I hope to show throughout this workflow, again, this is pretty simple at the moment, but hopefully you get a sense of just how powerful all of this can be. I have the ability to switch back and forth between the NativeScript app I'm developing here and my serverless code that's going to live in Azure up in the cloud. And I can do so really seamlessly. It's a really nice and fluid development experience. And at this point, my function is complete, but it's also just running on my local NPM here on my development machine. And my end goal is to have this code running in the cloud. Now, to upload this function, all I need to do is head to the Azure tab and find my function. So in this case, this is Hello World, and hit this upload icon. And the first time I do this, it's going to prompt me to create a new functions app. So this is the equivalent of what I was being asked to do in the portal earlier. So I can name this Azure or Acme Functions. I want this to be a Node 10 runtime. And I can choose between some of the many regions that Azure supports deployment to. So I'm in the Eastern US, so I will select this. And those steps are all I needed to really set up everything that needs to happen on Azure's end. Now, this is going to take a little bit of time since this is actually setting up all the necessary cloud infrastructure for us behind the scenes. So I'm going to switch and show the result of this momentarily. But while this is running, I want to show one other really cool feature of this workflow. So not only can your functions run in Visual Studio Code, but you can actually debug them here as well. So if I switch over and instead of starting my functions through here, instead if I start things up with the debugger, and to trigger, I'll wait till the debugger actually starts up here. And I will also set a breakpoint. And now if I head over to my app and I switch over, or Rob will switch over to Mira, you'll see that I actually now stop directly within my function, and I have a full JavaScript debugger within VS Code to work with. So I can do things like, if I switch my name up, so I was Mira, I can switch to Sebastian. I get all the things you'd expect out of a JavaScript debugger, like a call stack, watchers, and whatnot. And when I save that change and apply it through, you can see it is applied on my app. Again, just making all of this a really nice, a really compelling development workflow as you develop your NativeScript apps. And it looks like our deployment is now complete. So what I'm going to do is, I got to grab the, there it is, the deployed URL for this function. Copy that over. And I'll switch back over to my NativeScript app. And all I'm going to do is swap out this local endpoint with the production one. And when that refreshes, you can see that the functionality of this app hasn't changed in any way, but I'm now hitting my endpoint that has been deployed to Azure Functions in the cloud. It's really pretty powerful stuff. And I do want to do one more really quick example, just so that you can see this workflow in action in more of a real world scenario, at least something a bit more than Hello World. Now the Acme app has this little weather widget, and under the hood, if I bring up the file here, it's using OpenWeatherMap to actually grab the necessary data. Now this works, but Acme wants to move this code into a serverless environment with Azure for a few different reasons. The first is that they actually don't want to distribute their OpenWeatherMap API key publicly, which currently it's publicly accessible, and they don't want that falling into the wrong hands. And the second reason is they want to, or at least they want the flexibility to use this weather retrieving endpoint in more than one app. Maybe they need another NativeScript app with this functionality, or they might even have web apps where they want to leverage this weather data as well. So let's implement this in Azure. And what I'll do is I'll head back to our functions project. We'll just head back actually to the Azure's tab here. And remember that this icon here creates a new function. We'll create another HTTP trigger called getWeather. We'll again create this as anonymous. And I'm going to go ahead and paste in the finished code, which is basically the same code that I had over in my NativeScript app that's hitting this endpoint. But the one thing I do want to point out that I think is pretty cool is that because I'm operating in a Node.js environment here in this Azure function, I do have the ability to use existing NPM modules in my Azure Functions. So in this case, I'm using the Axios library, which is just a handy little utility for making HTTP calls in Node.js and web apps. And because of that, for this to work, if I close this, I will actually need to npm install Axios, though that it's a part of this function and available to use. And with that happening, let's go ahead and start this new endpoint. We'll start the Functions app up so that I have this new endpoint available to use. And so this is get weather. So I will go ahead and copy this endpoint and head over to my weather service. And I need to, fix this endpoint. So I'm going to put this in. I've got my query string that I'm passing. And actually, let's do, instead of San Francisco, let's do someplace where I'm at instead. I'll save this. You'll see that our app will refresh and things didn't change other than getting my location, which is exactly what we wanted. Because for Acme, they now have their API key living safely in Azure, and they also have more flexibility now that they have this function that they can run from essentially any app. Hopefully, this gives you a sense of just how easy Azure Functions are to set up and how easy they are to use in your NativeScript apps or wherever. And you'll see some more Azure Functions that work with data later on in this webinar. But for now, let's move on to our second topic, and that's Azure App Services. All right, so I'm back in the Azure portal, and you'll see that App Services is listed as another top-level option. And I already have an app service configured for Acme. And within the service, just by sort of perusing through the menu, you can get a sense of some of the things that App Services can do for your apps. Things like push notifications and authentication. To actually use these services in your applications, Azure publishes both iOS as well as Android SDKs for accessing these services within your apps. And because NativeScript allows you to easily use iOS and Android libraries, these services are really simple to integrate into your apps. And to make your life even easier, you can bring in the NativeScript Azure Mobile Apps plugin, which actually wraps those iOS and Android Azure SDKs, and which is part of the premium NativeScript Pro Plugins offering, which you can find at npm.proplugins.org. Using this plugin is as easy as running tns plugin add. And if I head back to our NativeScript app over here, and I open up the package.json, you can see that I have this plugin installed and ready to go. Now, the feature that I want to implement to show you out of these app services is authentication. And if I head to the page on authentication here in the portal, you can see that App Services allows you to connect to a number of different options like Active Directory, Microsoft accounts, and other third-party providers like Facebook, Google, and Twitter. Now, earlier I went through the necessary OAuth configuration to set up an Azure-based Active Directory instance and enabled it on this Acme app service. And what I want to do is integrate this authentication experience in the Acme app. If I head back to the app, and actually let me bring it up on the simulator, the first thing I want to do is switch over the router so that instead of going to the home screen, you users go to a login screen by default instead. And you'll see that there's two buttons for two different workflows, one for logging in with Active Directory and another for logging in with Google. And I want to show you both of these. And if I bring up the login component that actually drives this, you can see that the buttons right now are just wired up to call methods in a login service, which is where the core of the logic for driving this experience is going to live. And if I open the service, you can see just sort of, even by just skimming this before we get into the details, how relatively trivial this code is for some pretty impressive functionality. All you need to do to make this authentication workflow happen is first of all, import the appropriate class names from the Azure Mobile Apps plugin, instantiate a new client, providing the domain of your app services instance, which you can get from the Azure portal, and call the client's login method, which you need to pass the appropriate provider. And actually, let's see, it's going to be authentication provider dot, and you can see the 5 options that Azure supports. And then you also need to pass your app's URL scheme, which is something that you configure in your iOS apps info.plist. And this is something that's pretty well provided in the plugins README as well. And with just those handful of lines of code, you now have a fully functional Active Directory setup that you can integrate into your applications. And this same code that I have in this login service is actually going to work with all of the authentication providers that Azure supports. All I need to do is switch up this provider, which I think is actually kind of slick. I don't have any other provider set up on my Acme App Service, but the Azure Plugins demo does. So I'm going to switch over to that for the moment just to show you what this looks like. And before I show the full authentication sort of workflow in action, I do want to make one additional change to this app. Now, when I log in, I also get the user's name and picture from the authentication provider. And what I want to do is switch the Acme Apps home screen to actually display that information. So if I go back to our home component, this was the screen that showed that little weather widget earlier, I'm going to go into the component code. And instead of displaying that sort of hard-coded greeting, instead, I'm going to get the user from the login service. And then in my markup, instead of displaying that greeting again, we're instead going to show a message that grabs the user's name dynamically and also grabs the photo of them from, in this case, we're going to be grabbing it from Google. And after all that refreshes, I can head into this app. We'll go through and do the Google authentication workflow. It'll take me a second to go through this, type in my email, password, and then my verification code. I have to promise not to hack into my Google account here later. And with that, I am in. You'll see I'm taken to the home screen, and I have the name that I got from Google and my image as well. And the same is going to work with these other authentication providers that Azure supports as well. Really, when using all of these, the only real work is back over here on, if I go to the correct screen, doing the appropriate setup to actually connect to these services in the portal itself. And the good news is, even though this takes a bit of work, as it will with sort of any OAuth connection, regardless of what you use, Azure does a really good job providing sort of helpful links and documentation that can help point you in the right direction. Hopefully these demos have given you an idea of just how powerful NativeScript in Azure can be. With Cloud Functions, you can easily write serverless functions that you can use across all the apps that you write, and set up a pretty fast development workflow when working in NativeScript. And with App Services, you can integrate mobile features like a complete authentication workflow with multiple providers in just a handful of lines of code. Now, there's more coming, especially with Cloud Functions, so stay tuned for that. And to talk about what's next, I'm going to send things back to Rob.
Great, thank you, TJ. Next up, I'd like to transition to Stanimira Vleva. Mira is going to show off how you can use Cosmos DB and Azure Functions as well. Mira, the stage is yours.
Oh hey there, my name is Stanimira, and for the next 20 minutes we're gonna build a mobile application with NativeScript, Azure Functions, and Azure Cosmos DB. You're probably already familiar with NativeScript, and thanks to TJ, now you know Azure Functions as well. But what is Cosmos DB? Cosmos DB is Microsoft Azure's globally distributed, large-scale database service. It's been used to some of the best-known Microsoft products for the past decade, such as Skype, Xbox, and even Office 365. Okay, now let's take a look at the application that we're gonna be building. This application might look very familiar to many of you. It is the getting started point for every NativeScript Angular project. We have a list of football players, and when we navigate to a particular player, we have a form where we can update the details, like the name and the role. When we tap the update button, we navigate back and we have the updated player in our list. Let's take a look at the Android profiler now, and more specifically at the Network tab. Let's navigate again, and now we see in the profiler that we're doing an actual HTTP request, and the endpoint for that is Azure. Our goal today is gonna be to fetch the players from the Azure Cosmos DB database that we're gonna create and display them inside our application. First thing that we need to do is to actually create an Azure Cosmos DB account. The easiest way to do it is through the Azure portal. I already have a created resource group. Name shouldn't really matter. For the account name, I'm gonna use Cosmos DB-NativeScript. For location, I'm gonna select UK West. I already have an account, so I'm not gonna create this right now, but this is how you should do it. So let's go ahead and use the already created account. As you can see, I have a single container inside, which is the actual database. But if you need to create a new container, you can use the add container, type the name of the database, for container ID, you can just use container1, and for partition key, you need to use something unique. Partition key 1, for instance. And this is gonna create a new database for us. We can see that the database currently is empty. So in order to create a new item, we can use just the new item button and add some new players over here. Our players are gonna have a name and a role. As you can see, the rest of the fields are automatically populated by Cosmos DB. We can also upload a JSON file to populate the database. This is quite useful when migrating from another database like MongoDB or something else. So because in our sample application we already have a list of players, let's just go ahead and fetch them. The application that I have here is the initial NativeScript Angular application. I have created that by using tns-create, specifying the name mobile app, and specifying that the application is going to use NativeScript Angular as well. So if we go to mobile app and navigate to the item service, we can see that we have already a list of players. Once again, our goal is going to be to fetch them through Azure Cosmos DB instead of having them hard-coded. So let's go ahead and upload this list of players to our database. This already almost looks like JSON, but we need to convert it a little bit. To convert this object, I'm going to use a Vim macro. To start the macro, I need to use UW and then just perform the actions that should be taken on this specific line. I need to wrap the keys in quotes, and the IDs in Azure DB should also be strings instead of numbers. When I'm finished with my actions, I just need to go to the beginning of the line and then go to the next line and tap Q to stop the macro. To repeat it, I need to use add W. And because this works successfully, I'm just gonna repeat the macro 20 more times for the rest of the lines. Now I just need to wrap all that in an array, and that's it. Let's try uploading that. So let's remove this player over here and upload our document. See that 22 items were created. Let's refresh the database and we can see our items over here. Pretty cool. We already have a populated database. Next thing that we have to do is to create the Azure Functions project that we're gonna use to connect to our database, read data from it, and also update items. To create a new project, I'm gonna use Visual Studio Code and the extension for Azure Functions. As TJ already showed you, it's a great idea to install the Azure Functions extension or just the generic Azure Tools extension. Because I already have it installed, I can use the Azure Functions create new project command. And I actually want to create that in a new folder called DB Functions. I will use TypeScript for my functions. And it is important to specify the type of the functions. It is HTTP trigger. For the name of the functions, I'm gonna use players get because this is gonna be my function that is gonna fetch all the players from the database. And for authorization level, anonymous is fine for now. This is the code for my function, and I'm getting an error here from VS Code because I don't have my node modules installed. So let's go ahead. Let's go to DB functions and run npm install. When this finishes, I'm gonna have access to all the interfaces for Azure Functions. Okay, for now, let's remove all that over here and check out what else is in the project. We have some metadata in the function.json file that specifies the methods that are available for our functions and all the bindings for it. Because this is a getter, we should only support get method. Now we need to configure our function to work with Cosmos DB. In order to do that, we need to create a new binding. The type of the binding is Cosmos DB. The database name that we have should match our database name, the Azure portal, plus players app. The collection name is items. The connection string setting that we're gonna specify later is gonna be in the key Cosmos DB. And because we are receiving data, the direction of this binding is gonna be in. If you were to create or update data, the direction should have been out. What about our connection string setting? We haven't deployed to Azure yet, but first, when we deploy, we're gonna specify the settings for that inside local settings JSON. So here we're gonna specify the key Cosmos DB and actually go to the Azure portal again and grab the connection string from there. We can obtain the connection string from the keys tab over here. And we need to grab the primary connection string. Now, what else do we need? First of all, we need to specify the dependencies that should be installed. And we need to do that inside our host.json file. The key value for the extension bundle actually instructs Azure that it should be installing only its libraries, so we can talk to queues, databases, and pretty much everything that we can integrate inside our Azure Functions app. And finally, we also need to create a storage account. We can do that easily by going to the portal again, going to storage account. I already have some existing storage accounts, so let's use the player's storage account. Again, we can obtain the key from the access keys tab, look for connection string, and use that inside the local settings file. Save this file. Go ahead and save function.json as well. And of course, we need to specify a name for our function as well. This is gonna be the name of the document that we are receiving. And I'm gonna call that player document. Alright, let's write some actual code now. The players should be inside context bindings player document. Remember, this was the name of the object that we specified inside our binding in functions.json. So these are gonna be my players. So let's just go ahead and send them as part of the response. We also need to specify a status for our response, but the default status is 200. Just gonna keep it that way. Alright, let's go ahead and run our project. Then we can start our project by running npm start. Before doing that, make sure to have the Azure function core tools installed. Again, the installation instructions are different depending on your operating system. So when we run npm start, we're gonna have our functions available locally. So let's go ahead and test this out by setting a request to players get. And what we get back is a list with all our players, which is quite cool. Again, we haven't deployed our functions application yet, but we have our connection string, which is connected directly to our Cosmos DB database. So we're getting the actual data. And we can also manipulate it. Let's go ahead and create an update function now. We can do that by using the create function command in the extension, again specifying HTTP trigger. The name for that is going to be players update. And for authorization level, again, we're going to specify anonymous. We don't need any of that code, but we need to make sure we set up the bindings to Cosmos DB inside our function JSON file. But first of all, for the method here, we're going to have just a put method, because this is the right method for an update. And we're going to have the same binding as in the players get function over here, because we want to receive our players for the database. I'm going to call that document in. And we also need a binding for the player that we're going to be updating. We're going to have that as player document out. And it's important to specify that the direction here is out. What about the ID and the data of the player that we're going to be updating? Well, they're actually going to be part of the request body. So we have ID, name, and role, and we're fetching that from the request body. From that, we can construct the new player. And what about the old player? Well, we need to find that from the context bindings player document in, and search for a player that has the same ID as the specified ID inside the request. Then we can save that inside the context bindings player document out. We're gonna have the properties of the old player, and then we're gonna apply the properties of the new player. And because this is coming second, and the keys and properties are just structured, they're gonna overwrite the old player keys and properties. Pretty cool. What is left to do is just call context.done. Let's restart our server. It is gonna build the application again. And we can see that we have a new endpoint at localhost players update. Let's test this out by sending a new request. So for that, again, I'm gonna use curl, but I need some data that is changed. So let's just go ahead quickly to the database that we have over here. And copy this player. I'm gonna keep the same ID and just change the name over here. So I have to specify the type of the request, which is put, the data, which is inside data.json, and the endpoint that they have. Let's refresh our database and see what's happening with our player over here. Yep, it is updated. Pretty cool. So right now we are ready to go and deploy our application. See how we can do that again through the VS Code extension. Create a new function app, and I'm gonna call that webinar players. I'm gonna use Node.js 10, again West Europe. After the deployment has finished, we can go to the portal. Here we are, we have webinar players. And inside we have our functions. have player get, and we can get the function URL from here. And let's try to send a request again. We get the same data as before. Now we're ready to go ahead and integrate that inside our mobile application. I'm just gonna run you through the created application because the logic is pretty NativeScript specific. Let's run the application just to make sure that everything is working. First thing that we need to make sure we have is the NativeScript HTTP client module inside our application. And we can take a look at the item service now and see that we're doing actually HTTP requests with the HTTP client instead of having the items hard-coded. We're obtaining these from an endpoint. The endpoints for Android, you can see here, is just the local host for Android, and for production we are pointing to our actual Azure function URL. Inside the item component that we already have here, we're grabbing the item service and we are then obtaining an observable of the items that are going to be returned by the HTTP request. Then we're just displaying these items by using the async pipe in a list view, which means that whenever we receive a new value inside that observable, it's going to populate the items list and all our players are going to be displayed on the screen as we see them over here. We also need to make sure that on the details page, whenever we are updating our user, we are also sending an update request. Let's take a look at the item details component. Again, we have a form control data. We're using that inside our component template. And whenever we are tapping on the submit button, we are calling the submit callback. So we grab the updated item from the values of the form and we are sending an update request through our item service. Whenever the item is updated, we're just navigating back to our items page. Alright, that's about it. All the source code of the application is available in GitHub. So you can go ahead and find it in /NativeScript Azure Cosmos DB. And I'm gonna make sure that it's public after the webinar finishes. Okay, I'm gonna pass it off to Rob now. Thank you.
Awesome, thank you Mira, and thank you again TJ. So I have the pleasure of winding down our webinar today. So I'd like to finish up by looking at some of the more fun aspects of Azure, and that is the Cognitive Services APIs. Now, Cognitive Services are generally grouped into 5 categories: decision, speech, language, vision, and search. Again, we could hold any number of webinars to tackle all the APIs provided here. Instead, I'm going to chain a couple of these together, specifically from the language and vision APIs. But before we get to the really fun stuff, I thought it'd be useful to just briefly go through the quick process you'll need to go through on the Azure portal. So once you've signed up for your free Azure account, you'll want to create a resource. And next, if you're following along at home with my demos, you'll want to add the text analytics service, which is part of the Cognitive Services APIs. And of course, click to create said service. Pretty straightforward so far. And now we can wait as our deployment spins up. This usually takes no more than about a minute or two. And finally, with that service created, we are provided with the all-important key and endpoint. Please, for the love of all that is holy, never share your key with anyone. This is literally the key to your account, and if you mistakenly share it on GitHub, for instance, rest assured some bot will find it and start using it before you can say $10,000 invoice from Microsoft. Actually, I may be exaggerating there a little, but yeah, just keep it to yourself. Okay, with these simple steps accomplished, let's switch over to a demo. So here's the NativeScript app I created for this webinar, and like any other NativeScript app, it works equally well under iOS and Android. Now, this first screen leverages the Language Detection API. Imagine you're working on an app that might require the user's language. Maybe it's some kind of support app where you want to route requests to someone who supports the user's native tongue. Maybe it's some kind of, I don't know, translation app. Maybe I'm coming up with contrived examples. In any case, I can use Azure to detect the language I'm speaking. So let me start by enabling the microphone, and I can just say some text and close that up and hit the submit button. Sure enough, it's English, accurate enough. Pretty cool. Now I do know a little bit of Espanol here, so let me try that. Let me delete what's in this box first. Hola, amigos. I know, pretty advanced stuff here. Submit that. It's Spanish, so everything seems to work fine. That's pretty awesome. So now let's take a look at some of the code behind this. So for anyone new to NativeScript, this might look a little bit odd. It's a little bit HTML-like and also not. This is because with NativeScript, we are leveraging native UI elements. This means new elements like action bar and text field and label will all appear and button here. But the naming conventions are pretty straightforward. So you probably can see how the previous UI on the device equates to seeing an action bar at the top, along with a text input field, a submit button, a label to show a result, and a button to turn on or off the microphone. And finally a button that appears allowing us to head to the next demo. Now the JavaScript driving this page is going to be surprisingly simple. Now I've cut out some of the boilerplate here, but this is effectively all I'm doing to leverage these cognitive APIs. I have an endpoint and a path that constructs the URL for my request. I'm creating a post request here and sending along a content type of JSON and my Azure key in the request header. Finally, I have this body variable as my content. And what's that all about? Well, the body is a stringified version of a documents object. Now this documents object is simply an array of values with ID and text properties. This is what the Azure API is expecting to receive. So you probably guessed right that my text property is simply the text that I spoke in or entered in the text field provided. Now in the response to my request, I'm simply grabbing the JSON returned and parsing out the language name. You'll see an array is returned and I'm grabbing the first item of the array. Yes, this does mean that I can submit an array of values in my request and get them all returned in a single response. Finally here, I did want to show off how easy it is to add that speech recognition feature to this app. By using the NativeScript speech recognition plugin, I simply use the start listening method. You'll see I can set my locale, choose whether or not to return partial results, which just means results returned before the plugin thinks I'm done speaking. Finally, in this example here, I just output the text to the console. All very web-like. Okay, our next step is to go from language detection to sentiment analysis. Now the sentiment analysis API lets me analyze text and get an idea of how angry or happy a person is. Now this can be incredibly useful for triaging or maybe prioritizing support issues, maybe via a built-in chatbot or such. So let's use the same text and see what it says. So that looks pretty happy. You'll see the number next to the emoji there. The data returned is based on a value of 0 to 1, 1 being very happy, 0 being very upset. So if I remove this text and let's say, I'm super excited, and hit submit, so we get closer to 1. Or if I say, I'm super upset, that gets us way down to 0. So you can get something neutral. I'm feeling neutral. That's still pretty upset, actually. Was it more upset than feeling upset? That's interesting. Interesting logic there. In any case, let's see how this code looks. So I'll be honest, this is where things start to get a little embarrassing for me. Moving from language detection to sentiment analysis doesn't require many code changes at all. In fact, all I'm doing here is changing the path of my HTTP request to hit the sentiment API. Now the result is named differently, here using score. The only slightly unique thing I'm doing here is showing a different emoji depending on how close the returned value is to 1. The closer to 1, the happier the text sounds. Alright, next let's take a look at the key phrases API. Now this can be especially useful if you want to get at the most important parts of what a person is trying to say. So this would be useful if I have a lot of text to go through. Now, for example, since this is, after all, a Microsoft-oriented webinar, let's add some text about one of my favorite Microsoft products, and that is the Xbox. So I'll say, I really am into the Xbox. Now I wonder what the key phrase is going to be here. It's Xbox. Hey, no surprise there. So we can play around with this. I really am excited about this Azure webinar. And submit that. Well, Azure Webinar. Yeah, I guess maybe webinars would be a better way of putting it. But you get the idea there. Pretty cool. So it's going to analyze that text and pull out key phrases for us. Once again, let's take a look at the code and see what we had to do to make this all happen. Okay, it gets even worse here for me. You'll see that to add these 2 extra demos, I didn't have to do much work at all. And again, to extract key phrases, all I'm doing is tweaking the URL to hit a different API. And again, the result is a little different, reflecting the key phrases naming. It's really all that simple. Now finally, I want to transition over to one of the vision services, and that is the Face API. Now the Face API itself has numerous options for us, but in line with what we've been doing, we're going to ask the Face API to estimate age, mood, and gender for a given picture. So what you see here is a list, massive list here of attendees of a random meetup I picked from something in New York City. This is actually using the free and open meetup APIs, by the way. So I have this huge scrolling list, and this is one of the advantages of NativeScript here, no laggy scrolling at all. So let's pick someone here. How about Lauren here? And we're going to get, well, the prediction is that she's about 24. She's happy and she's female. Looks about right. How about somebody who looks a little bit grumpier? And this has got a little bit more neutral look here. And anybody that's sad? Let's see. How about this Mikey guy? Neutral again. How about just a blank avatar? It's just gonna barf, isn't it? Yep, no result returned at all. My app, this is not the most perfect app in the world. You see, I'm not overwriting the results if the result was invalid. How about Philip for one more? Another neutral looking guy. So you get the idea here. Pretty cool stuff going on with the Face API. There's a lot more you can do with the Face API, but that's more for another time or maybe a blog post. So finally, let's take one last look at some code to see how this was all executed. So I'd like to go over the Face API code in slightly more detail than the previous code samples. Recall that scrolling list in the demo. This is simply a list view provided by NativeScript. For each item in my items array, I'm creating a new list view item, which is made up of a grid layout, which you can think of as a table in HTML speak. Inside my grid layout, I have an image element and a stack layout, which is going to simply stack the containing elements on top of each other. And in that stack layout, I have a couple of labels. So this is all I need to make that performant list view. And to populate that list view, I'm simply using the HTTP module again and grabbing some JSON from that public meetup API for a random meetup in New York City. Now when I tap on an individual, you saw that this sent me to a detail page for that person. Here's the markup for that page. Again, same concepts as before. I'm redisplaying the image, and I have another grid layout / table, which contains a set of labels to output the responses from the Face API provided by Azure. And powering the detail view is again an HTTP request, similar in structure to what we did with the text analysis APIs. I have some additional parameters I'm sending to my request in this case, telling Azure I'd like to see a variety of facial attributes returned, like age, gender, and emotion. And finally, the result comes back, and I can look through all the emotion values provided. In this case, each emotion is returned on a scale of 0 to 1, much like the sentiment analysis API. The closer I am to 1, the more likely this is the primary emotion I want to display in my app. So to parse all this out, I simply load all those variables into an array, and I sort them with the sort method. And if you're curious about that compare function I'm using, it's just a standard little old JavaScript function I cheated and found on Stack Overflow. So that's really all it takes. I love this whole example because it shows off not only how powerful yet easy to use these cognitive services APIs are from Azure, but also how using some of the same constructs we're used to on the web work just as well in the native mobile world. Now, before we end today, I wanted to mention a conference that I think you would all enjoy. Progress is hosting JS MobileConf in Boston next week, actually, and we would love it if you could join us. JS MobileConf is a 2-day, 2-track conference focused on NativeScript, mobility, and the extended JavaScript ecosystem. If you've stayed with us this long, I am happy to provide a 30% discount code. Just use Azure Webinar when you grab your ticket. So check us out at jsmobileconf.com today, especially if you're in the Boston area. We will all be there as well, so you'll see content on NativeScript, of course, but also progressive web apps, augmented and mixed reality, serverless, machine learning, and much more. Again, that is coming up next week already, so maybe we will see some of you there. And with that, from all of us to all of you, thank you for attending. Please head to nativescript.org/Azure for a set of resources and more information on how to make the most of using NativeScript with Azure. Have a great rest of your day.